All right, so we're here, and this is our this is lesson 1, 2, 3. So that's always easier to remember. In previous math courses, so in Math 1 we should have used algebra tiles. We didn't use them very much, but we did use them every now and then. I wish we had used them more. So we're going to spend a lot of time with algebra tiles in this class. If you are unfamiliar with what algebra tiles are, please watch the algebra tiles video. The dimensions of the algebra tiles are shown above. Algebra tiles are named according to their areas. Label each of the tiles above. These tiles have a positive side and a negative side in the textbook, and anytime you see a picture drawing, the shaded side is positive and unshaded is negative. So this is y squared, this is xy, this is x squared, this is y, this is x, and this is 1. Okay. Use the following algebra tiles to build a rectangle: 1 x squared tile, 4 x tiles, and 3 unit tiles to sketch your rectangle below. So to do that, I'm going to go ahead and head over to CPM website. I'm going to throw off the things I don't need by dragging them back over here. And it said I needed, let me go back and look at my instructions. It said I needed 1 x squared, 4 x's, and 3 units. 1 x squared, 4 x's, and 3 units. One unit, 2, 3. This y needs to go back. So, and then trying to build a rectangle. So the first thing to kind of keep in mind is we're going to put our x's, x squared, our biggest one, in the upper left-hand corner. It makes it way easier if we do that the same way all the time. And then these, we're going to make it a rectangular array. We don't want to do this because then we won't be able to have a rectangle. So you can either build them like that or like that, and they go in the other corner. So I'm going to do this. And remember to change the orientation, double click, and it'll switch to, don't single click because it switches to negative, double click, and it switches around. So I'm going to put that one there, that one there, so there's my rectangle. So the idea is to build a rectangle. And building a rectangle is simple and easy, and we like rectangle building. It's very nice. I'm going to just take a picture so I don't have to draw that. You should try to sketch this as best as you can on your paper. It doesn't need to be precise or beautiful. It just needs to exist. I am going to use the joy of having a computer. Okay, so there is my drawing. Sketch your rectangles below. So do your best. It doesn't have to be perfect, but you should. I'm going to go ahead and draw one just to kind of help you see. So we got x squared, 3 x's. I'm going to label them all so I don't have to draw as carefully. 1, 1, 1, x, so that my picture looks like that. You see how they're all labeled in this picture? And so label the area of each rectangle. So basically they're saying put all the letters on it. You can use a snippet tool for your notes if you were using, putting this on a Google Doc or whatever, and you can take pictures like I just did, which I used a snippet tool. I used the one that's specific to this program, and do it that way, but make sure you're understanding what you're doing. Write a simplified expression that represents the whole area. So I have, remember the writing on them is the area. That's what we just said a minute ago. And so this is x squared plus 4x plus 3. Because there are 4 x's. I mean, I could just even read that, and basically that's my area. I just wrote it as an math. Write a simplified expression that represents the perimeter. So remember, the edge of this is x, and the edge right here is 1, and this edge is x. I'm going to put those as 3. This is 1. This is x. This is 3. This is x. So I have 4 x's, 6, 7, 8. That's my perimeter. Okay, so kind of keep that in mind, that difference in perimeter and area. Difference in perimeter versus area. It's very important. And as long as they're rectangles, the perimeter is not hard. If the shapes are awkward, the perimeter can be painful. All right. For each expression below, build a rectangle using all of the tiles if possible. So they're telling you what I need: x squared, 8 x's, and 12 1's. And so we want to write the equation as a product and as a sum and area. So I want you to kind of go back here. This is a simplified expression for area. One of the other things I could have written for the area is a multiplication problem. So I'm going to go ahead and just kind of clean up my perimeter here. I'm just going to talk about my edge. This edge is x plus 3, as you can see clearly from the bottom. And this edge is x plus 1, as you can kind of see from that side. So another thing I could have written is x plus 1 times x plus 3. And so those are both expressions of area, and this one is an expression of perimeter. Okay, so I want you to go ahead and build with algebra tiles, each of these, and try to make a rectangle. And if you can't make a rectangle, explain why you couldn't make a rectangle. So I'm going to go ahead and pause the video, and you need to pause the video, do all of these problems, and then come back. Because if you don't pause the video, you will not have any time because the answers will just be here. So take a minute, pause the video, do the problems. Answers will be up in just a second. All right, so here are the answers that I came up with. You'll notice again, I use my clipping tool to put the rectangles on instead of drawing them. So I've got x squared and then 6x's times x squared and 2x's. So x, there we go. And there's my dimensions, x plus 2. And so I like to look at this side to look at the edge. It's harder on this side for me sometimes, so that's why you see my writing over here. There's more than one right answer for B. This is the one I chose because it fit nicer on my screen. So I have 2x times 2x plus 2. I could have x times 4x plus 4. I could have 4 times x plus 1. So there's lots of different right answers on this one, just so you know. So don't feel bad don't worry about it if you have a different answer. I think that last one, 4, is wrong. It's 4x. So 4x times x plus 1. So there's lots of different correct answers. It's just a matter of finding the one that works for you. C was not possible. We need more ones. Like this is the picture I drew. I tried to arrange it all different ways. There just are not enough unit tiles. I need 5 more. Another one I might have needed because I tried one with them all on a line because that seemed like it might work. I just needed more ones. There's just no way. D is fine. I've got x plus y times x plus y, or x plus y squared. So there's my picture. So the only one that was not possible was C. So I hope you were able to come up with those answers. Let's take a look at the next problem. So here's a diagram to the right. We want to write it written as a sum equivalent to the area written as a product. So basically when we want parentheses and when we don't. So I have 6x squared. So when I'm looking for the sum, I'm just going to count what I see and count how many there are. So I have 6x squared and 9, 3, 6, 9, 9, 10, 11, 12, 13 x's, and then 6 ones. So there is my area written as a sum. And then for a product, I'm looking at my edge now. This is 2 x's plus 3. And this one is 3 x's plus 2. And so I have 2x plus 3. And then 3x plus 2. So there is my sum first and product second. And that's what we're looking for. Okay, next. You may recall using an area model like the one below in a previous math course. We tried to move on to these as well in Math 1. By using an area model instead of tiles, you can multiply expressions that are difficult to represent and get clunky and giant, and we don't want to. I don't want to draw 6x squared. I don't want to draw any of them. I'm going to be completely frank. I don't want to draw these. But by doing it this way, I don't have to draw them. I can just draw this. So you'll notice how is this similar? Well, there's the same number of x squared. There were 6x squareds, weren't there? And there were 9 over here and 4 over there. Those match. Let me do that in different. So those match, and this number matches. So they match. The same as this. Just this is much more compact. This is different. So again, you should write something down about how they're the same. It's different because I didn't have to draw the individual pieces. I was able to use the idea of the sum, that there were 6x squareds, and just write a total instead of all the pieces. So this takes up less space. It always can be a 2 by 2 square, if you will. You can always draw the same thing, and maybe a 2 by 2 rectangle, whatever way you want it. You can always draw the same thing and just fill it in. So regardless of what's happening. Now you'll notice they did this backwards of me. I like to put my x squareds up here, my numbers. So like this is my number, and this is my x squareds. They did that backwards, and these are my x's. But it's the same thing, so it's all good, okay? But that's what's happening here, okay? So here's some area model puzzles. And so again, I will be pausing the screen after I'm done explaining these, and you'll get a chance to do them. Fill in the missing dimensions and areas of each area model in the diagrams below. Then write the equation that shows the area written as a sum is equivalent to the area written as a product. So on these, I didn't actually write the sum. It did say write an equation. I did not see that. So I should have written as my equation 6x squared plus 13x plus 6 is equal to 2x plus 3 in parentheses times 3x plus 2 in parentheses. I should have had that written. I apologize. I didn't read the instructions. So that's what they're asking you to do, is fill in the missing pieces and then write down the sum, area as a sum, the equation, area, sum, equivalent to product. Okay, so again, pause your screen now and do these problems. I will be pausing my screen, my recording, and the answers will just show up. So make sure you pause. And so I have 3 times, so my missing thing was 3x here, because that's what I needed to multiply x by to get 3x squared. So you're kind of working backwards. I should have done one of these with you before I paused, but we're kind of working backwards. So x, so that's 3x, and then this is 2. And then this is, you know, you got 3x times parentheses x plus 2. I did this one the other way with the product first, so 3x squared plus 6. This one, again, what's missing? X times x to make x squared. X times nothing, so x times 1. So 1, 1. Anyway. And so I've got x squared plus 2x plus 1, which is equal to x plus 1 quantity squared, because I didn't want to write it twice. You can write it twice, or you can write quantity squared. Both are correct. This one, these two make 0, but I kind of wanted to write that down first. So I have 4x minus 9 equals 2x plus 3 and 2x minus 3. Over here, this one was quite challenging. It took me a little bit longer to figure out what was going on. What did I need? I needed a negative 2x. What did I need? Oh, that's going to be 6y. And then what did I need? I need negative 5. So then I looked at the top. So, okay, that's x. Because of this one. That's x. And so then there, and then there. Okay, then I combined all the like terms. So that these are the only 2 like terms. They made negative 9x. And then the dimensions. And so that's it. Pretty straightforward, pretty simple. And so your homework today is, I'll give you a couple of pointers in the next lesson, but your homework today is 3 problems from 111, this one right here, the perimeter, and then the flow chart, and then these ones. And again, there'll be another video. Okay, we'll see you very soon.